Hello and welcome. My name is John Hawkes and I'm the Land Manager for James, and it's my great pleasure to welcome you to this online intelligence briefing. Today, James Bingham, who's my Senior Analyst for Vehicle Weapon Systems and European Vehicle Markets, together with Nelson Fisk, the Principal Analyst for Land Warfare Platforms, will present a session entitled Active Protection System Developments. The IHS James Intelligence Briefing Programme will consist of approximately 40 events during 2017 and is available to all customers of James Intelligence Centre and module products, including the Markets Forecast product. But just before I hand over to James, I'd like to highlight that the information used to compile today's presentation has been drawn from a variety of James content, but particularly the James Defence Equipment and Technology Intelligence Centre, including the Defence Insight Reports, which are provided free of charge to all subscribers of that module.
Active protection systems automatically provide an interruptive or destructive effect on an incoming projectile that would otherwise be passively countered by the vehicle's armour. APS add layers to the survivability onion by extending the distance between the vehicle's armour and the destruction or degradation of the incoming projectile's capability. By destroying or degrading the threat projectile at a distance from the vehicle is less likely to be hit. If hit, less likely to be penetrated, and if penetrated, less likely to be immobilised or destroyed. APS can provide protection against a range of threat projectiles, including unguided shaped charge weapons, such as rocket-propelled grenades, anti-tank guided weapons, artillery rounds and airdrop munitions, and some tank-fired kinetic energy rounds. An active protection system provides situational awareness and detection of threat projectiles out to its furthest capable range. When such a threat is fired towards the vehicle, this is detected and tracked by the APS, which can deploy a soft kill obscurant, such as multispectral smoke, to interfere with the projectile's targeting and guidance mechanisms. Alternatively, the soft kill APS may use laser dazzlers or other electro-optical interference systems. If only a hard kill APS is fitted, or if the projectile is not neutralised by a hybrid APS's soft kill system, the threat projectile is targeted by either a deployed or distributed hard kill countermeasure. The former is launched from the vehicle and then uses explosive force and or fragmentation to destroy the projectile, while the latter uses an explosive fragmentation effect fired directly from the vehicle itself.
Germany has a history of developing a number of defensive aid systems, including obscurants, acoustic hostile fire location sensors, laser warning systems, and other components that can be integrated with soft kill APS. The country has developed a number of soft kill and hard kill APSs, and it's the first Western country to fit a soft kill APS as standard on its new build fleet of Puma infantry fighting vehicles. This is the Multifunction Self-Protection System, or MUSS, and it's manufactured by Hensel. The selection of MUSS for the UK's Medusa program in July 2016 is also a reflection of the system's maturity, which is understood to have reached Technology Readiness Level, or TRL 6. The MUSS uses a laser warning receiver and ultraviolet missile launch detector with incoming threats detected by one or both of these sensors mounted in the sensor head. The jammer head directs an infrared signal from a SAGM-ARROW NG jammer toward the threat. The two 76mm grenade dispensers can project multispectral suppressive smoke charges to a full 360 degrees. The AVEPS was developed through the Standoff Active Protection System, or AWIS program. The Active Vehicle Protection System Hard Kill APS was designed to equip a range of armored vehicles, and the AWIS became the AVEPS following a series of trials mounted to the Leopard 2. The AVEPS uses a Ka-band search and track radar infrared sensor technology to detect, classify, and track incoming projectiles with an unspecified cueing sensor. One or two of the effector launchers are then automatically slewed in the required direction of the threat with a processing computer used to coordinate the sensors and effectors. Israel is the only Western state to have operationally developed and use a hard kill APS, and that's in the form of the Trophy. While principally focused on hard kill APS solutions, such as Trophy and Iron Fist, as well as reduced weight light versions, the country has also developed soft kill solutions in order to layer projective efforts using both kinetic and non-kinetic means onto the projected vehicle. The APS was first unveiled in May 2015, with Aselsan having funded it from 2008, given the current uncertainty around Turkish tank procurement, though, particularly the recent reversal to sole source the Altay, the associated procurement of the Akkor system, it really could be uncertain now. When first unveiled in 2015, serial production of the Akkor was envisioned to begin in 2017 to allow the APS to be installed on the first batch of Altay tanks. And this makes Turkey the first NATO member state to plan on equipping its new build tanks with a hard kill APS. The Kingdom is following a twin-track approach to its future APS acquisition through the Defense Science and Technology Lab, or DSTL. The first, known as the Active Integrated Protection System, or AIPS, Medusa Technical Assessment Program, is using the MUSS system to develop an understanding of how high maturity systems can be incorporated onto existing platforms such as the Challenger 2 tank. The integration of MUSS onto a Challenger 2 could lead to an acquisition of the APS as part of the Challenger Life Extension Program.
Russia was the first nation to develop and field an APS, this being the DROS system that was employed on a number of T-55 AD tanks from 1983, as well as on some T-80U M1 MBTs. It is a hard kill system that relies on unguided 105mm fragmentation interceptors. Subsequently, the DROS 2 was developed, with this still being marketed, but never having entered production for the Russian army. A successor, the Arena APS, and its related export version, known as Arena E, was developed in the early 1990s. Using different hard-kill EFP plates, the Arena system is not believed to have entered service with Russian forces, but is understood to have seen some degree of technology transfer or integration work onto the South Korean K-2 tank. There are a plethora of sensors that have already been developed for use on aircraft that could be transferred to the land domain for use by APS. These include missile approach and laser warning receivers that could be adapted for use as the sensory component of an APS. As such, if these components can be transferred rather than developed outright, this is likely to generate cost, schedule, and technical benefits. The use of an open systems architecture could support the integration of such components into an APS, with components produced by different manufacturers integrated into a common data exchange. While open systems architecture offers a number of advantages for the end user, including the avoidance of technical and commercial lock-in to a single or small number of manufacturers, and the ability to integrate a variety of different components, the border between intellectual property rights and an open architecture is currently unclear. There are commercial implications required to implement an OSA approach to fielding an APS. Determining which entity becomes the design authority for the system, for example, as well as the logistical, engineering, and through-life support requirements for supporting a variety of system components. Active protection systems will remain at the forefront of military ground vehicles technological development in coming years. The potential for these systems is yet to be fully realized, with the high complexity of such systems posing substantial technical challenges.
So that does now conclude the seminar. Thank you very much for joining us today for the event. We look forward to welcoming you to future online briefings. Our next briefing, which is on airborne ISR towards multi-mission and increasing automation, is going to be held on Thursday, 27th of July at 1500 UK, 10 o'clock EST. Thank you very much for your diligence today, and goodbye.